Hello, everyone. Thanks for joining the CSSL webinar, Computational Social Science Lab at the Faculty of Social Science at Chinese University of Hong Kong. My name is Jeroen van der Meijden. I'm an assistant professor here at the School of Architecture and happy to serve as host today to welcome our esteemed guest, Filip Biljecki from National University of Singapore. Welcome here to the Zoom. I'll give a quick introduction and then just hand over. Filip Biljecki is an urban data scientist and professor at the National University of Singapore, where he has established the NUS Urban Analytics Lab. Since its founding in 2016, the lab has received funding from NUS, Singapore's Ministry of Education, industry partners such as Takanaka Corporation, Japan, and published more than 150 papers in Q1 journals, including 2015 paper on application of 3D city models, which received almost 1,000 citations. 2021 landmark paper by Biljecki and Ito on street view imagery and urban analytics and GIS, published in Landscape and Urban Planning, which received more than 600 citations. Filip has a background in geometric engineering and GIS science, and is jointly appointed at NUS by the Department of Architecture and the Department of Real Estate in the NUS Business School. He holds a PhD degree in 3D GIS from the Delft University of Technology in the Netherlands, where he also did his master in geomatics. He was awarded the Presidential Young Professorship by NUS in 2020 and has many different additional roles. Too much to mention here, but just to select a few, he is associate editor for the journal Computers, Environment, and Urban Systems, subject associate editor Urban Analytics for Landscape and Urban Planning Journal, principal investigator with the Future Cities Lab at Singapore and ETH Center. Received many awards, including 4 teaching awards between 2021 and 2025, Urban Informatics Paper of the Year award to 2023, and was listed by Stanford University as one of the top 2 scientists worldwide recently. So we're very honored to have you here, Filip. Thanks so much for joining, and looking forward to your lecture. I'll just hand over to you now.
Okay, thank you very much, Jeroen. Thank you for the comprehensive introduction and for having me here. And thanks everyone for your time this morning. So in the next 45 minutes, I'd like to share with you what are we working on at our research group. I will start first with a general overview of our research agenda and different examples of research. And then I will zoom in into our research line on urban digital twins. So I'm really happy to get connected more with your lab after I was at CUHK last year for a short visit, and I visited a few departments as well. So Jeroen did my job about introducing myself. Thanks again. Then I will skip this slide. So I come from NUS, which is the largest university in Singapore. So Singapore, like Hong Kong, has several universities, and NUS is one of them. It's a comprehensive university that has 17 schools, and I come from 2 of them, the Business School and the College of Design and Engineering. And one of the departments at this college is my department, the Department of Architecture, which is in many ways similar to the School of Architecture at CUHK. So beyond the architecture, we also cover landscape architecture, urban design, urban planning. And in the last 5 to 6 years after I started, after I joined this department, I started a new research area on urban analytics and geospatial analytics. We have about 50 full-time faculty and 70 adjuncts, and we are quite an international department with more than 14 nationalities represented. We have also a large set of education programs with more than 1,000 students, and we also have a PhD program. So let's talk more about my research group that I established at this department when I joined several years ago. So we grew to about 20 full-time researchers, including PhD researchers. And we are the first such research group in Singapore that focuses on a wide range of topics under the umbrella of urban informatics. Because we fill this gap as a first research group, our mission is also to take part into community building. So we are not only doing research, we are not only involved in education, but we are also organizing guest lectures and seminars and so on. So most groups in the domain of urban informatics, they tend to specialize in one domain, for example, transportation and mobility. But in our research group, we decided to take a bit of a different approach. We decided to build our own set of ingredients to make the most out of domains and latest developments in urban data and computer science. So primarily, we have been focusing on building a strong foundational geospatial research. That means that instead of focusing on a particular domain, we focus on foundational research, such as developing new ways to assess spatial data quality, developing new ways to acquire spatial data, and developing new methods to harmonize and standardize data. So this kind of focus helped us to become specialized in particular types of urban data, on top of which we then build a multidisciplinary research agenda in urban informatics that doesn't cover a single discipline, but it covers multiple domains, also like urban climate, urban comfort, real estate, and even a bit of urban design. And as a result of this mix of different focuses, in the last few years, we focus on different projects, such as developing new ways to analyze urban morphology that could be useful for urban climate, real estate, transportation, and so on. We have also been working on energy and sustainability studies. For example, the map you see in the middle, the yellow dots on a black background. This is one of our projects on mapping solar panels in cities. And third example is a map that shows a glimpse into some of our mobility research. So we have built a new way to analyze network data in cities. Another important context is that we are based in Singapore and the heart of Southeast Asia. So Singapore is in many ways similar to Hong Kong, so I don't have to give you a lot of introduction. We also have lack of space. We also have problems with humid climate and so on. So our research has been influenced by these factors. And also our research has been influenced by the fact that we are in the center of Southeast Asia. So we are also focusing on topics that are relevant to the rest of Southeast Asia. And what are the main streams of urban data that we are focusing on and building our expertise in? These are primarily crowdsourced data or volunteer geographic information. Of course, like many groups in urban informatics, we take advantage of government data. We wrote many papers that have heavily relied on data from authorities, but at the same time, we think there is a lot of value in crowdsourced data. So different kinds of user-generated geographic information that may complement government data. Of course, this is primarily OpenStreetMap. I think most of you are familiar with OpenStreetMap, but one of our missions is to look into different kinds of crowdsourced data that has never been taken advantage before. I'll give an example in a moment. And besides writing papers, like most academics, we also develop open source code and open data. So you might have heard of some of our recent open projects, like Urbanity. This is a open source software that allows you to embed semantics into network analysis. And the latest open source software that we released is Voxcity. It's a new 3D GIS software that allows you to cover the entire pipeline of 3D GIS, from getting the data, processing it, and analyzing it for different environmental simulations. So we think that we as academics should not only focus on traditional output like papers, but we should also take the lead in enriching the community with open source and open data. So before I move on into digital twins, I'd like to give you an example how all these things come together. So I'd like to show you one paper we wrote a few years ago that combines our interest into crowdsourced data and our focus on building a foundational geospatial research agenda. So we are continuously exploring different kinds of crowdsourced data that may be useful for urban studies. And one data stream that kind of went under the radar in the last few years in our community are Airbnb reviews. So most people who stay in an Airbnb, they leave a review about their stay after they're done. And usually in these reviews, they tend to describe their experience in the accommodation, like how clean the apartment was, how welcoming the host was, and so on. But when looking into this data, which can be scraped relatively easily, we also notice that people like to talk about their experience with the neighborhood. So people usually write things like, the host was a great person, very welcoming, helped us a lot in navigating the city. The bathroom was very big, it was very clean, but we didn't really like the neighborhood because it didn't have many restaurants, or I didn't feel safe walking towards the accommodation because it was dark and it was a bit shady. So what we've done in this research, we have built a pipeline on analyzing all these millions of reviews across cities and extracting relevant information about neighborhoods. So we found that Airbnb reviews typically contain 5 topics that are relevant at the neighborhood scale, like perception of greenery, perception of public transportation accessibility, crime, noise, and density of amenities. So we have analyzed the sentiment of people focusing on these 5 topics. And because these Airbnb listings tend to be spread all over a city, we are able to create maps like this. This is an example for London, in which we can map the sentiment of people when it comes to a particular aspect like crime. For example, in this map of London, the different colors represent the perception of greenery. So people like also to talk about, oh, I really like staying in this house because the neighborhood was very green. I could jog every morning or walk. So this paper that was published in Cities is a good example of what our research agenda is about. We are continuously looking into new channels of crowdsourced data that can help us improve urban sensing. And this is a new way to reveal insights in cities, especially from the visitor's point of view. Another data stream that has been of particular relevance to us is street view imagery. I would say that this was the main data stream in the last few years, thanks to which we have developed contributions relevant for different domains. We like street view imagery because, in addition to traditional geospatial data sources, it allows us to get the human-centric point of view. and it often allows us to get insights that have not been possible with other kinds of data. Another reason why we like street view imagery is that thanks to the impressive advancements in computer vision that are becoming very difficult to follow, we are able to unlock many use cases and opportunities. For example, one thing we have been regularly working on is mapping the urban form. So street view imagery allows us to map the amount of greenery at a pedestrian point of view at a very high resolution. Or it also allows us to map the sky view factor. All these are metrics that are quite common in different domains like urban climate or real estate, mobility, health as well. Another aspect we have been routinely looking into is the human perception of streetscapes and perception of urban design. For example, we have been conducting surveys, like many other research groups around the world did, on understanding how people feel about a particular streetscape, like how beautiful it feels, how safe it feels. And we are able to conduct studies that are automated thanks to the wide availability of this kind of data and thanks to the developments in computer science. But besides these traditional use cases, we have also introduced some new use cases, like mapping soundscapes. So Singapore, like Hong Kong, has a problem with noise. Lots of places are quite noisy, and we need accurate noise maps. But the problem is collecting data for these noise maps can be quite complicated and expensive because it's quite difficult to measure noise at a high resolution at a city scale. So we have developed models that allow us to predict the amount of noise from images. And because we have street view imagery available at the city scale, we are able to create noise maps at the urban scale at a high resolution. And another thing we have been, I would say, even pioneering is change detection. So street view imagery is not really a new data set anymore. Companies like Google Street View, Baidu started collecting this data about 15 years ago. And since then they have been revisiting and remapping streets, which means that now, 15 years later, we have imagery available from different periods. And this rich set of temporal data allow us to map physical changes in ways that was never possible before. So it allows us to detect different kinds of changes in cities that are not possible with traditional techniques like satellite imagery. And another new direction we have been looking into is nighttime data. So all this data is typically collected during the day, but we thought that maybe there may be value in collecting data also during the night. So we have been establishing prototypes that reveal new insights in cities from nighttime data that we have been collecting in Singapore, like urban vibrancy during the night. And let me just give you an example of a paper we publish relying on street view imagery before I go into digital twins. So in a paper that we publish in Landscape and Urban Planning, we have introduced a new way to cluster different urban scenes. So we develop an unsupervised learning approach that takes all images in a city. I'm talking about hundreds of thousands of images, thanks to providers like Baidu and Google. And this approach automatically clusters different kinds of scenes in a city. For example, in Singapore, we found that there are 6 predominant typical scenes. And because we do this research at the city scale, we are able to create maps of cities that indicate the spatial distribution of these different types of scenes. And beyond that, we are able also to track the temporal evolution of these scenes. So we are able to conduct these analyses across different years in the last decades to understand how the street scenes and their design have evolved in the last decades. And if you're interested in these topics and in general this kind of data, but don't know from where to start, I'm happy to advertise ZenSVI, which is an open source software package that was developed by one of our PhD students, Koichi, that allows you to conduct most of these analyses out of the box. So Koichi's idea was to develop a one-stop solution that would allow you to download the data, analyze the metadata, transform the data, run the most common computer vision approaches like semantic segmentation, and visualize it. And beyond that, you're able to export the generated and analyzed data into some other software. And this software is extensible, so we always welcome contributions in case you want to extend the software. For example, one thing that the software was extended with was access to the street view imagery of Amsterdam. So some local governments around the world, like the one from Amsterdam, they started recognizing the potential of this data, and they started collecting this data on their own. And they released this kind of data openly. So we also develop an extension that allows you to download data from Amsterdam in case you are specifically interested in it. But the reason why I'm here today, after this long introduction, is to talk about digital twins. So naturally, like many other research groups, we couldn't escape from this topic. It's quite relevant. And we also like digital twins, like many other things I talk about, for many reasons. One reason is that digital twins are growing in relevance for governments. For example, we like the idea of digital twins that they can help us improve scenarios and decision-making in urban management. So the idea of digital twins is to build a scenario in the digital world, run different kinds of simulations to predict how would it be successful in the real world. And then after you find the optimal scenario, you implement it in the real world. And many implementations have been done around the world about digital twins. In Singapore, we have a government initiative. I know that in Hong Kong, you also have one, for example, the one led by the Lens Department. And there are many other notable initiatives like the one in Japan called Plateau. This is particularly impressive because it covers dozens of cities across the country, and it provides open data. Another reason why we like digital twins is that they started spanning multiple scales and domains. For example, some years ago at NUS, we had a project funded by the government to bridge the building scale and the urban scale. And in fact, academia has been quite active in the ecosystem of digital twins. So today, besides government initiatives, we also have many university initiatives that enrich this topic with their research, but also software, data, and standards. For example, my former group at TU Delft, the 3D geoinformation group, has been quite active in this space. They have been developing a standard called CityJSON that allows you to easily exchange data on 3D models. And also they have been developing a nationwide 3D model of the Netherlands, including 10 million buildings, that is completely open. And they also develop a web viewer. Another exciting non-governmental development on digital twins is that a lot of data can be crowdsourced, which you can imagine is quite of our interest. For example, at the bottom right, you can see a screenshot of a 3D model of Singapore. but one that has not been created in a government initiative. This one has been sourced from OpenStreetMap and other data, creating a detailed 3D model of downtown Singapore. And also there are movements like working groups, like the one in the Open Geospatial Consortium, which I'm part of, the 3D Information Modeling Working Group, and the Urban Digital Twins Working Group. So all these different stakeholders, different streams of data make this topic quite of interest and worthwhile our time. But also there are some challenges that we noticed in the last few years and some opportunities. We find that lots of things are unclear, like terminology, like what is actually a digital twin? Everyone is talking about digital twins, but if I ask 10 people in a room what a digital twin is, I will likely hear 10 different things. So also there is a challenge of the lack of standardization and also integrating all these efforts together. Another challenge we notice is that a lot of these developments are quite driven by technology and focus on technology. So we like to say they're techno-optimistic. And I'm also quite excited about that. I'm an engineer by training, so of course I'm excited by the technological developments. But we also notice that humans are a bit excluded in this loop, and there is a lack of focus on less technical topics. Another thing is that these digital twins, they're hungry for data. Usually you need different kinds of data to make them happen. But this data is often not easily available, especially in less developed countries. And at the same time, these digital twins can be quite expensive and complicated to build. So in order to justify these costs, you need to provide convincing use cases and applications. However, the developments in use cases have been kind of stagnating in the last few years. Research on new applications have been kind of atrophying. And that has been a challenge for digital twins because you cannot get funding to build a digital twin if you don't have convincing business models or use cases. And a promise of digital twins is to create this two-way loop between the real world and the digital world. However, we notice that in practice, this doesn't really exist. It's very rare to see a two-way loop. So digital replica of the real world, but also in the other direction, implementing scenarios that have been simulated in a digital twin. There are some efforts that implemented that, but efforts that do that in real time and do it meaningfully are still very uncommon. And finally, lack of open solutions is another important challenge. So many of the solutions are quite commercial, and that adds to the complications. So I'm here to present some of our research efforts that help solve these gaps. Of course, I will not pretend that we have a solution for all these problems, but I'd like to present a sample of some of the research that we have been working on, in particular 4 types of research that try to at least a bit diminish some of these challenges and problems. Most of our efforts related to digital twins are part of this NUS project called BEAM, which is led by a few colleagues, including me as co-PI. So this is a project that is funded by the university with the main aim to make our campus more comfortable to staff and students and visitors, and with another goal of reducing the ambient temperature by a few Celsius degrees. It consists of 4 components. The first one is baselining. So in order to understand the reduction of temperature and increasing comfort in the campus, we have to set a baseline. What is the current temperature? What are the current conditions in the campus? This is what B in the acronym BEAM stands for. The second part is evaluation. So as part of the baselining, we need to find critical areas in the campus, like hotspots, that draw our attention to places that need most intervention to become more comfortable. The next component is action. So when we identify the baseline and critical parts in our campus, we need to find what are the best courses of action to mitigate that situation. And for that, we develop simulations, like typical environmental simulations. And it goes without saying that for this, you need a digital twin. And finally, when all these actions are implemented, we need to monitor them to understand how successful they have been. So as you may infer by now, a digital twin is a key technology in this project to allow us all these components. So let me give you a sneak peek of how the current version of the digital twin looks like. So as part of the project, we have integrated data from 40 weather stations in the campus that provide us historical and real-time data about climatic conditions in the campus. For example, temperature every 1 minute. And this digital twin doesn't allow us only to get the current situation, but it also allows us to check the historical data. This digital twin has been built on open technologies. So at the moment we are using DeckGL and Cesium. As part of this project, we also want to demonstrate that it's possible to build a completely open solution for digital twins. And now that I gave you a background of our broad project, I'd like to move on to the first topic I'd like to talk about today, is making sense of the state of the art and improving the definitions. So lots of research groups, lots of companies, many local governments, they talk about digital twins, but it's often really difficult to communicate across different communities and across different institutions if we don't really have standards. Primarily a standard of what is a digital twin and what makes a digital twin qualify to be called a digital twin. So when we started getting more into this topic, we were even more confused than before we started. With each new paper we read, we find a new definition. And that led us to an effort in which we decided to come up with a definition on our own, but instead of coming up with a definition on our own from scratch, we decided to crowdsource the definition. So we have analyzed 15,000 articles published across different communities, like urban planning, real estate, and so on. And we use natural language processing to understand if we can come up with a definition that would be a composite of all these definitions. And we came up with a definition thanks to analyzing all these thousands of articles that goes as follows. An urban digital twin is a spatial temporal virtual representation of a real-world urban area or city, mirroring its states during its life cycle through IoT sensors. It is used to monitor and analyze urban systems across different time spans to aid in decision-making and can be extended to simulate and predict various states and scenarios. So when we came up with this definition, of course, we realized that we cannot take 15,000 definitions and put them all together. We also noticed that a lot of them are conflicting with each other. So as part of this work, we have also understood what are the outliers, because in this corpus of 15,000 papers, even though we tried to come up with a consensus, we found that some definitions completely conflict with that. So in this paper, we have also analyzed conflicting interpretations of digital twins and identified outliers. But probably more importantly is that as part of this research, we realized that it may be a bit difficult to come up with a singular definition of a digital twin amid so many conflicting definitions and understandings. So we realized that there isn't really a single digital twin, but actually digital twins come in different shapes and flavors, which we call maturity, different stages of maturity. So in collaboration with a researcher from Harvard University, we developed a digital twin maturity model that characterizes digital twins based on how mature they are. So these digital twins, most of them, they tend to adhere to our definition, but they give more justice to different stages of their development, from relatively basic and static 3D models all the way to autonomous real-time digital twins that have achieved a two-way loop. And besides the definition, we thought that, okay, now that we have a definition, maybe a definition is not that useful if we don't really provide assurance or enforcement of this definition. So we started working on benchmarking of digital twins in order to verify if a certain initiative can actually be called a digital twin or a 3D city model, and in order to understand how good it is. So of course, these initiatives, they tend to come not only in different stages of maturity, but also different stages of quality. And we thought it would be useful to provide a benchmarking initiative to assess them. So in a project called 3D City Index that was developed by one of our PhD students, Binyu, we focus primarily on 3D city models, which are the backbone of urban digital twins. In this project, we identified 47 criteria that we could use to assess the properties of a digital twin. For example, what is the level of detail, how frequently it is updated, and what was the last time it was updated. And in this research, we go beyond the data itself and these technical details. We also focus on the quality of documentation and accessibility. For example, is there a web viewer to see this 3D model or digital twin? What is the quality of documentation, and is there software developed to support using it? And we benchmarked more than 40 cities around the world, mostly in Europe. Not to rank cities how good they are, but rather to understand how different the initiatives are across cities. And one of the goals of this work is to help cities position their efforts and compare them to what other cities are doing, to help them to learn from each other. So in this research line, we have been developing standards and efforts to define what a digital twin is, and what makes it good, what qualifies something to be called a digital twin. But we think it's also important to ensure that this definition is adhered to and understand, do different efforts qualify to be called a digital twin. The second research line we have been looking into was inspired by talking to many practitioners. So when you go to conferences and events, everyone is quite excited about digital twins, but not many cities and not many companies have really adopted digital twins. So in this research, we wanted to understand what are actually the challenges, what are the problems to the adoption. And this research was also led by our PhD student, Binyu. She has conducted not only a systematic literature review, but she conducted a global survey of experts in digital twins across academia, local governments, and companies. So she interviewed experts in multiple stages according to the Delphi survey method to understand what are the different hindrances to the adoption of digital twins in practice. And she has listed an inventory of about 50 different challenges why digital twins are still not adopted fully around the world. And she split them into technical and non-technical challenges. For example, among technical challenges, we have interoperability as a prominent obstacle, and among non-technical challenges are aspects like capacity building and trustworthiness of digital twins. Because this research was conducted according to a Delphi survey, we went back and forth with experts. And after we identified the challenges, we asked them to provide rankings of severity. So not all these challenges are equally complex to solve. So we have been focusing on rating them according to how difficult they are to fix. And the number one challenge that experts around the world cited is the lack of interoperability of semantics. For example, the architecture industry is using different taxonomies than the urban analytics community. So this was one of the main challenges that people have identified. And of course, there are less technical challenges like lack of business models that especially people working for local governments have outlined as one of the key challenges. The third research direction under our umbrella of urban digital twins is looking into developing new use cases and integrating new kinds of data that have never been integrated before in a digital twin to try to unlock new value and new use cases. And I'd like to show you a few examples of proof of concepts that we have developed in the last few years. These are not at the practical or commercial stage. These are still at the proof of concept stage, but of course we are always open to have this implemented in practice. So as part of this BEAM project, in which some of my colleagues are active in, like my colleague myself, we have been looking into how can we integrate the notion of urban comfort into a digital twin to understand how people feel in the campus and what drives their comfort. So what we've done is integrated different kinds of data that has never been integrated before. For example, we installed infrared thermal cameras. I think all of you remember thermal cameras from COVID from a few years ago. They were everywhere. And what we've done, we bought long-range thermal cameras that can measure temperatures up to a few kilometers away. And with that, we have been able to build a data stream that measures the temperature of buildings or in particular their facades. So these cameras, they take thermal pictures every 10 seconds. And we built a data stream that integrates this real-time channel into a digital twin. And we can also inspect, I'll go back, we can also inspect historical data to understand how hot the building was on a particular day on a particular time. So this is the first time that this kind of data has been integrated in a digital twin. Of course, thermal cameras are quite old. They are a technology that was developed and implemented many years ago, but for some reason it was never really implemented in a digital twin. And putting all these data streams together, we think that could help us unlock new use cases and provide more value to digital twins. Another data stream that we have integrated in a digital twin for the first time is data from wearables, in particular from Apple Watches. So we distributed dozens of Apple Watches to students and staff in our campus to understand where they move and how they feel when they move in our campus. This project was conducted in collaboration with another research group, the Building and Urban Data Science Lab at NUS, which is specializing in comfort. So integrating this data in a digital twin allow us to not only, I'll play the video again, allow us not only to inspect the data, but also link it to other factors like what people see when they walk. So at the top right of the screen, you can see an image at each point where a person walks. This image was not collected by the person walking. This image, Street View imagery, was collected by our research groups all over the campus in order to understand what people see while they walk. And then if we link all this data, including weather stations and traditional GIS data like digital elevation models, we are able to understand what drives people's comfort in the campus. Is it the amount of greenery? Is it walking uphill, downhill, or is it simply temperature and humidity? So now we are working on multiple models that are able that help us understand what, not only to explain the comfort in the campus, but also help us predict comfort in any part of the campus based on different conditions like particular temperature, amount of greenery, and so on. We think that humans are quite left out from digital twins. So we have been also looking into different kinds of data that has not been integrated before in a digital twin. And one of them is human visual perception. So there has been a lot of research done in the urban studies community on understanding how people feel about different urban design and different streetscapes. Most of this research, they focus on street view imagery. They run large-scale surveys asking people how safe this street feels to you or how wealthy this street feels to you. And there have been literally hundreds of papers conducting this kind of work across different cities with different kinds of focuses. And one thing we notice is that buildings, which are a very important component of the built environment, have not been really an important part of these studies. So we realized that architectural style also influences the perception of people, and in general, the size, shape, and presence of buildings plays an important role in the perception of people. How this kind of aspect has never been part of these studies before. So in this research, we focused on the perception of buildings and architectural styles across different cities. We focus on Singapore, Amsterdam, and San Francisco. And we conducted a study that includes hundreds of participants rating hundreds of buildings across different dimensions, like how original a building feels to you, how boring, how complex, and so on. We collected so much data that we could establish an automated approach to predict the scores of each building in each of these cities that is visible in Street View imagery. And then we thought, okay, we have all this cool data for almost every building in a city. We know how people feel about its architecture. but wouldn't it be fun to integrate it in a digital twin? And this is what we've done. We developed an extension to the standard city JSON, and we integrated for the first time these perception scores, like how boring or how complex a building feels. So in this platform, people can click on any building. By the way, this is a prototype of The Hague in the Netherlands, but it can be scaled to almost any other city. People can click on a building and then see the score, how this building feels to people. And now we are looking for use cases of this kind of data. So we have built this data set, we have introduced it into a digital twin, and ongoing research is focused on making the best out of it and understanding what use cases could benefit from that. One of the use cases we had in mind is routing. So finding the best route that would expose you to the nicest architecture. This may be important to visitors to a city. And another use case we have been looking into is more related to urban planning and design, and also has some relationships with participatory planning. We built a proof of concept to simulate different scenarios of buildings in a street to understand how people would feel about that new building before it's constructed. This was done in many cities before. Usually cities conduct surveys, they ask people, they have exhibitions, but we thought that we could bypass that process and automate it with a digital twin, building a system that would allow us to rotate different permutations of buildings with different sizes, shapes, and architectural design. And then it would help us automatically understand what would be the one that would be liked by people the most. And this is a proof of concept, but we already published it in cities a few months ago. It was semi-automated. We didn't reach the full automation yet. We have manually built scenarios of different new buildings next to the Singapore River, and then run it through an automated approach of rendering these scenarios and automatically rating them using our models. And let me show you a sneak peek of a video that shows how this digital twin of the Singapore River looks like and how we conducted this survey. So we collected a lot of street view imagery around this building. We created a very detailed 3D model based on which we rendered, based on which we integrated new designs and rendered them in a very realistic images. And then we conducted VR studies to understand what is the visual perception of this environment, thanks to which we have developed an automated model based on which we can rotate different scenarios and automatically predict which of these would be most liked by people, completely bypassing surveys. And finally, I'd like to talk about the fourth topic that we are working on. So digital twins are data hungry. Often, many cities don't have the required data to build a digital twin and conduct some complex simulations. For example, for building simulations, for building energy simulations, often you need a lot of data about buildings. You need to know how tall a building is. You need to know what kind of building it is. You need to know the shape of the building and so on. And this kind of data is more often not available than it's available. So it's available sometimes from government sources, sometimes it's available from crowdsourced sources like OpenStreetMap. For example, this is an example from OpenStreetMap at your university. It has, in OpenStreetMap, you can find excellent data, thanks to which you can build a digital twin, and one that will likely be useful for different simulations like building energy simulations. However, often it happens that within the same city, like somewhere else, you don't have any data at all. So this is another example from Hong Kong, close to the airport, that also shows OpenStreetMap. So it's within the same city, but it doesn't really have information about buildings. Like we don't know how tall this building is, what kind of building it is, and so on. And if you don't have these essential ingredients to build a digital twin, you cannot build one, and you cannot conduct critical simulations like building energy simulation. And of course, getting this data is quite expensive. Not all governments can afford it, and not all cities have an army of volunteers to crowdsource them like in OpenStreetMap. So then we've been looking into, is there something we can do to help fill these data gaps? And what are the possible new ways to collect data on buildings? And that brings me to another crowdsourced data stream that has been almost completely ignored in the community in the last few years, but in practice, it has been quite prevalent. And these are real estate ads. So if you search for to rent an apartment or to buy a house, you will likely go to marketplaces that look like this. You have a lot of information about the property, like pictures from inside, information like price, how big the apartment is. But what we notice is that often these ads contain a lot of information about the building itself. They have pictures on the outside, showing the facade, showing the amenities. And often they include information like how old a building is, how tall a building is. And we decided, hey, wait a moment, these are all the information that are quite useful for digital twins and for domains like building energy simulations. But there is a disconnect. This data is on websites like real estate marketplaces, and no one actually took advantage of this data and built a bridge to our community. So we thought these data are a type of user-generated or crowdsourced geographic information that has been completely ignored in our community. And a few years ago, we have built a prototype that we published as a paper in Urban Informatics. By the way, Urban Informatics is a journal, in case you're not aware, it's a journal started in Hong Kong by Paul Yu. So I'd like to also use this opportunity to advertise it because it's a relatively new journal, but I think it would be maybe of interest also to you. So we published this paper in which we present a proof of concept of extracting this data thanks to a scraper and showing how can it be useful for not only digital twins, but also broadly for the urban community. So we found different kinds of uses of these real estate ads. For example, filling data gaps, which is the most obvious one, but not only about information about buildings, like how old a building is, but also amenities like swimming pool and so on, things that could be detected from images. We also found these data stream as useful to predict new buildings. So in Singapore, like I guess in Hong Kong, new properties that are not yet built are already on the market. And we realized that we can take advantage of these ads to build digital twins of a future scenario. So it's very rare to find data on buildings that covers also future buildings that are yet to be built. But we thought that it would be quite relevant to have them in digital twins because they could help us to run simulations for future scenarios for buildings that are going to be constructed in the next few years. And this work helped us to fill these data gaps, to take advantage of a new data stream that was never used before in order to provide more rich information to digital twins. So that brings me to the end of my sharing. I'd like to end with some takeaways. So we think that, yes, all the technological stuff is needed. It's also very exciting, but in order to do truly meaningful research, we need to have a lot of clarity about different things like definitions and standards. We need to have a standard of what makes a digital twin, how good a digital twin is, what components it must have. Another thing that we found is that it's really difficult to deliver the actual promise of digital twins. So achieving a two-way loop between the real world and the digital world, especially in the other direction, to run simulations in the digital twin and then implement it in the reality. Another thing that I would like to highlight is that we think that we shouldn't forget about the human aspect. So things like human perception have been ignored in digital twins. And with our research, we like to give more focus on that. And finally, we think that we academics cannot work alone on that. We really need collaborative ecosystems involving also government and industry. And this has been quite challenging. Breaking these silos is a must, but quite challenging. And before I finish, let me just advertise a special issue that may be of your interest. So as you have seen from my presentation, we are quite into open source software. And we think that it's quite useful to have more open source software in the community. But one problem with academia is that it doesn't really value these efforts enough. Of course, academia primarily values papers, not practical outputs like open data and open source software. So I started this special issue with the idea of trying to mitigate these shortcomings. So I joined forces with a few colleagues from the community to have this special issue specifically dedicated to open source software papers. So if you have been developing an open source software and you want to write a paper about it, we would greatly welcome it in our special issue in CUS. And we set a very long deadline to give you a lot of time. So the deadline is in about 1 year. So there is no excuse not to consider it. So I hope that some of you will consider our special issue in case you have developed some tool that you released openly and want to get adequate academic credit for it by writing a paper. So I'd like to end here. Thanks a lot. If you want to learn more about our research, feel free to visit our website, follow our LinkedIn page, and connect with us. Thank you.
Thank you so much, Filip, for amazing lecture, taking us all the way through the kind of early days of your lab and the most current research on digital twins. Super interesting to see your overview of the possibilities and also the challenges, right? And how you're actually contributing to the global field on sort of addressing these challenges. I would like to invite, I hope you have time for a bit of Q&A.
Well, let's do that. Yeah, welcome.
Yeah, that's great. I would like to invite any questions from the audience, either by just voicing out through the Zoom here or typing into the chat function in Zoom. I have some questions as well, but I already saw from Professor Tony Tan, Director of Computational Social Science Lab. He may have a question for you. You can see if you want to ask it here. Yeah.
Yeah, I'll voice it. Thank you, Filip, for taking the time to share with us such a visionary research program. I'm a sociologist, not particularly technical, but I'm really interested in how you deal with the input side and the output side. By input side, I mean really the technical thing. In sociology, we have since long ago, tried to build a developmental map for China, breaking down China into different pieces, counties, units, smaller units, and then embed lots of informations, socioeconomic informations to it, creating both the spatial and the temporal evolution of a whole bunch of data series. That has taken us a long time at CUXK. They regard it as a treasure for World China Study. And it was very difficult to get the data in manually. And it's even after that, users find it difficult to use. So my question on the input and the output side are related to this analogy. In your case, you have much richer data. Is a real modern sense of big data in front of you, out there, everywhere, from different sources. There are different barriers, but there are also different data types. In such a difficult space of a sea of data, how do you manage the vision of a future automated system? Are you going to, from the beginning, to start thinking in AI terms, using machine learning approach, automate the whole process, or what? So this is something I'm really interested in, how you visionary team think about such a challenge that to me is just mind-boggling. On the output side, once you have all this data archived somewhere or somehow stored somewhere, how would you provide it for the user on the output side? If I'm not so ambitious to get the whole thing, I just want to study a health problem, urban health problem. I have a question about environmental health, and I want to draw from bits and pieces of your digital twin database or archive. How do you expect a user can conveniently use it? If not as simple as downloading a few variables, what would that be? Can you clarify both the input and the output side for me as a sociologist? Thank you.
Okay, thank you, President, for the question. Thank you for having me at your lab. Okay, I don't know from where to start. It's a bit complex. But yeah, this is definitely a challenge, quite a challenge, and we recognize this early, and that's why we have been working also on the research on standardization and harmonization of data. I'll go back to one of the initial slides. I think you joined later, so I'll just go, I'll focus on this. So we recognize that, yeah, the input part has been quite a challenge, which has been compounded by all these new data streams coming in. And that's why we decided to focus on not only developing harmonization approaches, not only participating in international standardization organizations, but another important factor is quality. So we have been developing new ways to assess the quality of spatial data. We don't really have a solution for that because it also takes a lot of time to develop a new standard. And there are always continuously new data streams coming in, like, for example, data from wearables and so on. But I can definitely acknowledge that it has been a challenge. And in fact, we spent quite some time on that. But perhaps something worth mentioning is the challenge of academic value here, because all these are mostly like engineering challenges. And the amount of time spent on fixing and improving these issues often may not be worth in academia because papers about topics like that are really difficult to publish. So there is a challenge. Often we need to work on that, but at the same time, often this challenge doesn't really translate in academic value. So that's another challenge that I would like to highlight. When it comes to the output side, one thing we have done to help practitioners and colleagues in the adoption of the work, especially if they're less technical, we have been working on developing open source software. And also, we released a lot of data openly. For example, on the left side of the slide, you see a black map with yellow dots. This is a project in which we have built a system to map solar panels in a city. And we have released open source code for that. And at the end, this gives you an output like data about the locations of all solar panels in a city, their locations, and so on. However, we noticed that even though we have released this code openly for practitioners and colleagues in the field to run their analysis, we noticed that there are many people who are a bit less technically inclined or simply don't have time to run the software. And we noticed that that definitely jeopardizes our the adoption of our work. So what we started doing then in projects like that, we started also releasing open datasets that people can simply use off the shelf without ever having to run the code. So we have been generating all these outputs as open data and releasing them for the community covering different cities. So I don't really have like a solution, like a complete solution for that, but releasing stuff openly, especially open data, I think definitely helps in the adoption. One thing that I must admit that we are still working on is the adoption of our results among government agencies. I don't think we are the only ones having this problem, but I think the bridge between academics in urban studies and practitioners is still something that we need to work on. And when it comes to going back to the input, I think I'm quite optimistic about LLMs. I think LLMs might help us make more sense of some of the input data, especially from textual data, like I talked about before. For example, in this research that we have scraped millions of reviews from Airbnb to understand the sentiment of people about neighborhoods. This research was done a few years ago before ChatGPT became popular. And I think that now it would be far easier to make sense of this data and organize it, interpret it, and even standardize it. Yeah, I don't think this fully answers your question, but these are some hints. How are we working on that?
Thank you. Thank you.
Thanks so much. Yeah, just to follow up thought, it's interesting you point out, Filip, the difficulties as an academic when you're working on cutting edge research and proof of concept, and other groups that may be working on really big scale implementation projects like city governments and things like that. And you may actually know other research groups or people working for government. Do you see in the future that more cities would have a sort of dedicated department of scientists managing these massive models, which obviously academics wouldn't have time to really build and develop, to ask some of, to deal with these questions that Tony raises, right? That if you have a sort of a universal model for a whole city that has so many different layers, it becomes so difficult and costly to manage, especially for people to kind of come and and take some useful information out for the specific task that they're dealing with. How do you see that in the future? Would it have to be hosted by local government or in collaboration with academia or specific consultancies? How do you imagine that?
Okay. Okay. So first, I don't want to sound like too pessimistic, because I also want to highlight one case where our work was adopted by local government. For example, this project on mapping solar panels. In the end, it was adopted by a local government agency here in Singapore. So sometimes there is a way. Well, most often these solutions stay as a paper. Some of them have been implemented. Going back to your question, what I really like is the idea of national labs. For example, they are particularly predominant in the United States. I think they have been so far the most promising way of bridging academia and practice. So I like my job in academia of developing proof of concepts, of reaching only the early technology readiness level. Of course, I would be quite happy to see my stuff implemented in practice, even commercialized. But at the same time, I don't think we academics often have bandwidth for that. It's also not really our job. It's not always also fully valued. Some universities, they have started supporting startups. They even have offices who liaise with the industry and government. But inherently, I think academia maybe shouldn't focus that much on this topic. And that's why I really like the idea of national labs, not only in the US, but I know that in China, there is also this concept to take over initially developed concepts from academia and bridge them to commercialization and practice. And one disadvantage of smaller jurisdictions like Singapore is that there are only few national labs.
And maybe another follow-up question. I'm still looking at the audience as well, if they type anything. But in the meantime, because in the computational social science lab, which has a kind of mission statement to look at the sort of complex behavioral data and to understand complex social phenomena, right? And you obviously have shown already that you're working on things like perception, human comfort. Do you imagine linking this to behavioral studies and understanding both sort of individual behavior to understand, maybe environment psychology a bit better, or also sort of collective behavioral patterns, which help us understand, the flows and patterns of cities and predict them in case, maybe there's emergencies or events or policy changes, right? How do you see the contribution of digital twins for this kind of very complex human behavioral prediction studies?
Yeah, so I am quite optimistic about digital twins for this purpose. We had some fragmented work on that, one in which your PhD student Sifan was involved in while visiting us for the last 1 year here at NUS, in which she linked digital twins and emerging forms of urban data with her research on restoration. So she has been working on collecting data from smartwatches, but in the context of restoration, to understand what are the influences of the built environment. And one potential future direction would be simulating different scenarios in the built environment to find one that would be most suited to support restoration.
Yeah, and collectively, have you thought about projects or work on projects that look at sort of larger behavioral trends?
No, we haven't been working on that yet.
Okay. Maybe something we can think about. Any other questions from audience? Just checking at the chat. But there's a general message about CSS. Or Tony, do you have other questions for Filip?
Not right now. I am still trying to imagine how all these things may be relevant to other disciplinary research problems. It's really, really rich. I actually suspect that mainland China has been doing data collection, compiling digital twins to the best of their ability for quite some time. Just that we academics do not have access to their data. That's why when you do construct your data digital twins, I immediately thought about if it is just for government purpose, they can do whatever. They get tons of data, infinite amount of data, but then it's always about our real life and about academic research, whether we can be a user and get convenient output of it. Just having mountains of data somewhere on a supercomputer doesn't help us. So I was just wondering how things can be streamlined other than creating bits and pieces of extracts. That is the easiest way. But how is it possible to have an interface that can convenient people can query without writing programs, can still query? Say, just like when we talk to a large language model, we are essentially talking to a huge database, right? A simplified database, billions of parameter model of that complexity stores a lot of information. So a simple query generates outputs. That kind of interface will be, at the end of the day, I hope your vision of the digital twins can become highly useful, convenient, and useful resource for researchers.
Yeah, that will require a lot of research funding, but yeah, will be nice.
Yeah, that's my dream. Thank you so much.
Yeah, thank you. And just to add to that, it's not to compare different cities, they have different reasons, but the Singapore model is really great and already famous, right, for being a kind of a very generous and open source, sharing data with labs all around the world is a kind of this very smart strategy to get other groups like MIT to do research on Singapore that the Singapore government can say, thank you very much, and we'll take that research and maybe use it. And it's very interesting to have a sort of open platform where lots of researchers can maybe plug in to explore unforeseen new ways of using the data, right? That the government maybe even not have been thinking about or commissioned through research funding. It's very interesting to have this kind of open ecosystem where lots of players can try to experiment and find new ways of using the data also in very disciplinary, broad sort of multidisciplinary ways. Yeah, so maybe instead of just having a lot of data sets available in the future, I don't know, Filip, if you think there's a sort of platform where we can just tap into the live stream where things are being almost real-time updated and we can sort of collaborate in that way.
So yeah, some cities have made great advancements with Open Data Portal, but it will take many years to achieve the integration and especially of real-time data together.
Yeah, that's just maybe a dream or a sort of a vision for the future.
It's also a dream, I would say, yeah.
Yeah. In the meantime, it's been really great to see, how you actually have been one of the main contributors to what we just talked about, to using Singapore as a great example for research worldwide to understand how digital cities, digital twins in particular, can help develop new kinds of research with all sorts of potential meaningful applications for improvements in society in a real meaningful way, whether it's related to health or well-being, sustainability, obviously, one of the most pressing challenges of our time. Maybe with that, we will wrap up the session, if that's okay. Thank you so much again for sharing
Thank you.
your work.
Thank you. Thank you very much.
Thank you.
Thank you so much.
Thank you.
Hope to see you in person someday.
Yeah.
Yeah.
I was at CHK last year, just a few
Very
ago.
good.
So I hope to visit
Yeah.
again.
Yep.
Yeah,
You're
hopefully we
welcome.
can have a in-person invitation at some point as well with our little lab
Yeah.
in the School of Architecture.
Yeah.
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 Thanks so much,
Okay.
everyone.
See ya.
Thanks for joining.
Thank you.
Take care.
We'll close the Zoom, I think. Yeah. Thanks, Filip.
Thank you. Bye.